Okay, class, so this is 5.1, which is on simplifying trig identities. So you should start by going to the Moodle and printing out the 5.1 PowerPoint slides so you can do the problems and follow along by taking notes with the video. So here are some of the tricks and tips that you should be using, which is basic algebra, but using the trigonometric identities. So first we are going to simplify cotangent of alpha, and this is a Greek letter called alpha. So the trick that we're going to use here is to rewrite it in sines and cosines. So we know that cotangent is known as cosine of alpha over sine of alpha, and secant is known as 1 over cosine of alpha. So when we rewrite in terms of sines and cosines, we see that the cosine of alphas cancel and we're left with 1 over sine of alpha. So all we did so far is use the algebra that cancels it out after we rewrote it using sines and cosines. And 1 over sine alpha we know is cosecant of alpha using the reciprocal identity. And we have simplified it. So we know we're done simplifying because we don't have a fraction and we can't, there's not two things to add together or anything. So problem 2 has a secant. This is the Greek letter phi. So secant squared phi times tangent squared phi plus secant squared phi. We notice we have a secant squared phi in both terms. So that looks kind of similar to if you had like ax plus a. You have that a, and if this was an algebra class, you would just factor out the a and have a times x plus 1, kind of using the reverse distributive property. So we're going to do the same thing over here with our problem, but we have the secant squared phi that we were pulling out. So we have secant squared phi and times it by tangent squared phi. And here we have that coefficient of 1 that's not written, so we can just say plus 1. And so if we were to distribute that back in, we would get what we started with, which is good. And tangent squared phi plus 1 is one of the identities. So you need to look back at the Pythagorean identities. And looking at the identities in your book on page 350, you see that tan squared phi plus 1 is one of the Pythagorean identities. The Pythagorean identity is 1 plus tangent squared of u equals secant squared of u. So we can replace the tangent squared of u with the secant squared of u because it is equivalent. Instead of u, we have the phi. So we have secant squared of phi times, in parentheses, is secant squared of phi using the Pythagorean identity. Pythagorean identity. And right here, algebraically, this is if you have an x squared times an x squared, you add your exponents, 2 plus 2. So instead of an x, we have a secant, so it's secant to the 4th phi. You're adding your exponents. Okay, so we are done simplifying it. We know we're done. There's no fractions, so we can move on. Okay, so for this problem, this is very similar to something you'd see in an Algebra 1 class in quadratics of x squared plus 2x plus 1. So in our problem, we have a sine squared theta plus 2 sine plus 1. And remember, sine squared theta is the same thing as sine of theta squared plus 2 times sine of theta plus 1. So it's very similar to this algebra problem, but instead of our x, we have a sine of theta. And in algebra class, if you were given x squared plus 2x plus 1, you would just factor that. So you would factor it x plus 1 times x plus 1. And for those of you who learned the box method, x plus 1 and x plus 1, when you multiply it out, you get the same thing. Remember, you add that diagonal there to get your x squared plus 2x plus 1. So similarly, instead of an x, in our problem we have sine of theta, so this factors as sine of theta plus 1 times sine of theta plus 1. And over on the algebra side, x plus 1 times x plus 1 is the same thing as x plus 1 quantity squared. So we can write this as sine of theta plus 1 quantity squared. And we are done. Moving on to problem 4, we have two fractions with different denominators we want to subtract. So you're taught if you have two fractions with different denominators that you want to add together, you need to find a common denominator. So the common denominator is just the product of those two. So we have to multiply our first by secant of y minus 1 over secant of y minus 1. And then the right-hand side, secant of y plus 1 over secant of y plus 1. So when we do that, our first term, we multiply it by 1, becomes secant of y minus 1. We're going to subtract off secant of y plus 1. And that's all over the common denominator, secant of y plus 1 times secant of y minus 1. So we added the fractions by finding a common denominator, and we combined it into one denominator. So our denominator we can just multiply using FOIL or the box method. And in the top, we just have to make sure that we distribute the negative. Whenever you have a negative here, you're always going to need to make sure you distribute the negative to all terms on the right-hand side. So we end up with secant of y minus 1 minus secant of y minus 1. So our secants cancel on the top. And in the denominator, if we have secant of y plus 1, and I'm going to use the box to multiply it out. You can use FOIL or box. We have secant of y minus 1. When we multiplied it, it's secant of y squared, secant of y minus secant of y and minus 1. The middle terms cancel out, and we're left is secant of squared y minus 1. Secant of squared minus 1, you should notice, is one of the Pythagorean identities. So, if you look at the Pythagorean identities on page 350, IDE, page 350, you look for the Pythagorean identity that has the secant squared in it, and you see that 1 plus tangent squared u is secant squared u. And if we rewrite what I have in red to look like what we have in purple, by subtracting 1 to the other side, we see that tangent squared u is secant squared u minus 1. So the secant squared u is tangent squared u. I'm going to replace this denominator with tangent squared u. So in the numerator, I have the minus 1 minus 1, which is minus 2 over tangent squared u. And tangent is the reciprocal of cotangent, so this is minus 2 cotangent squared of u. So remember, the reciprocal identities is 1 over tangent of u is cotangent of u, and that would be true with the squares as well. So it is the reciprocal, and I no longer have a fraction. I can't have any fractions to add to each other. There's nothing to factor anything, so I am done. That is simplified. And on to problem 5. So on problem 5, this is something that you should see factor. So when you have cosecant squared x minus 1 over cosecant x minus 1, in the algebra world, that looks like x squared minus 1 over x minus 1. So in algebra, you would say, oh, you should factor the top, that's difference of squares. That factors is x minus 1, x plus 1, and the denominator is x minus 1. So you have to have really good algebra skills in order to see that. So the x minus 1's cancel, and you're left with x plus 1. So we're going to do the same thing with our trig, except we have cosecants. So when we factor the numerator over here, we have cosecant x minus 1 times cosecant of x plus 1, and the denominator stays the same as cosecant of x minus 1. So this top is the difference of squares, which is just one of the factoring patterns from Algebra 1. And then the cosecant of x minus 1 cancels, and we're with cosecant of x plus 1. And that is actually simplified as much as possible. There's no fractions, nothing to factor, it's all the way down. So that was problem 5. So this is when you notice when you have factoring. So you will see factoring come up, difference of squares, and simple factoring. And that would be the end. So what you need to do is look in your book. So I would like you to read the examples in your book. So that is page 350. Look through all the examples on page 350, 351, 352, and 353. So there's 7 examples in your book that you should go through before class tomorrow. And then in class, we will work on the classroom assignment, which would be problems from the book. If you want to get a head start, you can look at those. They are on the homework cover sheet, which is posted on Moodle. Have a good night.